Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program today. We have a really good one for you today because, cutting edge, like there's, the stuff that comes out every couple of months from, I know just yesterday we talked about the Sora. If you didn't see that, that's the generative AI from OpenMind that, or I should say OpenAI, that generates videos from a prompt using AI. That's a very different kind of thing, and that stuff is cutting edge too. But I think what Ralph has is like a step beyond that, even more cutting edge, like sharpest knife in the kitchen cutting edge, and that's what we have for you today. Ralph's found a number of great stories, and if you haven't joined us for one of his segments, then you're in for a treat, because I think today's going to be a lot of fun. And obviously, Ralph, our science and technology trends correspondent, will be with us today. And before we get to that though, computeramerica.com, we have a whole segment dedicated to him and all of his segments. You can find it there at the top. And of course, anywhere on the website, you can check that out. We have links to social media, stories, reviews, articles, stuff like that. And ladies and gentlemen, go ahead and check that out at computeramerica.com. So with that being said, I think, again, just welcome into the program. I hope that you're having a great day and you are ready for a great weekend, and you sit back, relax, and hopefully you enjoy the show. Because today, as I've said like 3 times already, Ralph Bond, our science and technology trends correspondent and everything that comes with it, joins us here today to talk about a number of fantastic stories, that number being 4. Ralph, welcome back onto the program. How you been?
Yeah, it's great, Ben, and it's great to be back. And one thing to mention, of course, come out to computeramerica.com, get what we call the show notes for today's show. We have 4 stories for you, and we also have some honorable mentions at the end. So we got some homework for you. And each one of the stories will have links and pictures and additional information. You can dive deeper into each story, because what we do is just give you the highlights. And what Ben and I do every Friday is look at what's going on in robotics or medical technology, sustainable energy technology, transportation advances, space research, physics, all across the board. And again, we just give you the highlights. And if you want to dig deeper, get those show notes at computeramerica.com, and it'll really enhance your experience.
For sure. And of course, if you're watching, you'll be able to see videos and stuff like that. But don't worry, We'll have everything in one place afterwards. And I got to say, like when it comes to renewable energy, Ralph, we've talked about a lot of different kinds. And I just want to tease that story number 3 is such a different take on one of the problems with renewable energy, and it's very fun, and I like story 3 a lot. So
yes, me too.
Yeah, so everyone stick around to that. But hey, we're not going to start with story number 3. We're going to start with story number 1. And for those longtime listeners, everyone knows that Ralph, of course, has a storied history with Intel, and of course, just being on the show for a long time. And processors are really up his alley. Well. And I'm sorry, processor story number 2. I'm getting ahead of myself. Story number 1, though, is about RAM, a different part of the computer. And, Ralph, this is, I keep track of a lot of technology, and some of the terms and definitions in this story I'm not even familiar with. So yeah, let's jump into story number 1. It's different. It's very different.
Yes. Well, when I saw this headline, how could I possibly resist? Liquid metal RAM, which means random access memory, folks. So liquid metal RAM is first step towards shapeless computing, as well as spineless robots with octopus-like features and robots from a popular 90s sci-fi movie. They're talking about Terminator 2, as you'll find out. This is a story from techradar.com. Really, I mean, again, irresistible headline, right? We've got to go check this out. But I'm going to warn you right up front, This is extremely geeky stuff that I certainly don't pretend to fully understand every element of it. But bear with me, bear with us, because we're going to plow through this. Because again, the idea of shapeless, or pardon me, flexible shape shifting RAM could be a component in going forward in robotics in ways that we've only dreamed about in movies like Terminator 2, right? Okay. So with that said, let's get into the story. Of course, we all know data storage systems are critical parts of our electronic devices, our computers, our phones, everything, right? But current methods have struggled to create flexible memory due to inherent rigidity limitations. Seems pretty obvious. But in a breakthrough that brings to mind the T-1000 robot from the movie Terminator 2. We alluded to that a moment ago. Researchers from Tsinghua, and I hope I'm saying that correctly, it's Tsinghua, but I played it and listened to different ways to pronounce it, and it sounds basically like Tsinghua. Tsinghua University in Beijing have developed a fully flexible, resistive, random access memory device, which they call Flex RAM, using a gallium-based liquid metal to write and read data. Now, one of the things that I do in the show notes to augment the articles are written for a very intelligent audience, way above my pay grade. And so they assume the reader knows a lot of these different things. So what I do in the show notes, folks, and why I want you to come out and look at them, especially if you're listening to us only on a podcast, is get the additional information. So, for example, I put in a note, gallium. They're talking about gallium-based liquid metal to write and read data to make flexible RAM. Okay, so what's gallium? Well, gallium is a soft, silvery white metal similar to aluminum. Okay, so this new liquid metal RAM, which can withstand nearly any deformation, uses reversible electrochemical oxidation to modulate the overall conductivity of the target liquid metals. Oh boy. Okay. So wait a minute. Electrochemical oxidation. They're talking about how they get the on-off, semiconductor feature in this liquid metal. That's what they're talking. They're saying we're doing it with electrochemical oxidation. Okay, side note, I had to insert this for my benefit. What is electrochemical oxidation? Electrochemical oxidation is a very efficient, advanced oxidation method typically used to degrade pharmaceuticals in wastewater. Wow.
News to me.
Ben, isn't that something? This is a great example of researchers. We see this time and time again, don't we, Ben? Where researchers look and say, well, over here in this field, they're using this technique or this material to do this, but I wonder if it could help us over here, right? I just love it. I wonder, frankly, I just thought about this. I wonder if AI helped them discover this possibility. I don't know. I'm going to stop because in the show notes, I have more about what this is all about, electrochemical oxidation, more details, more geeky stuff that I'm not going to torture you with on air here. But again, the show notes, you can come out and get more information. So let's get back to the story. Published in the journal Advanced Materials, and I have a link in the show notes to that. The research details how gallium-based liquid metal droplets undergo oxidation and reduction mechanisms in a solution environment. Now let this sink in. These liquid metal droplets undergo oxidation and reduction mechanisms in a solution environment that mimics the hyperpolarization and depolarization of neurons, aka nerve cells. Another example of looking at in nature, in our nerves, they have this thing called hyperpolarization and depolarization. Hey, maybe we can apply that over here to get liquid metal to be read and write, random access memory, right?
Further goes to the point, Ralph, that a lot of people look at, it's like, what's the most powerful computer, advanced computer, so on and so forth.
Yeah.
And the typical joke is everyone points to their brain and goes, your brain's super powerful, and it.
Yes.
Today's most advanced computing is, and this is a great example, is learning from our own brain and starting to behave more like a brain. So yeah, makes sense.
Exactly. Yeah, you're right. So it's again another example of saying the researchers going, maybe they said to themselves, how does the brain do this? Maybe we can do that in our liquid gallium RAM. Okay, so this unique process allows the writing of zeros and ones with a low voltage oxidizing the liquid metal to represent 1, and a reverse voltage returning the metal to its low resistance state of 0. Folks, I warned you this was geeky at the very beginning, right? And then a little side note here. Hyperpolarization is when the membrane potential becomes more negative at a particular spot on the neuron's membrane, while depolarization is when the membrane potential becomes less negative or more positive. So that's that on-off factor that they're learning from our own neurons in this hyperpolarization process. Okay, back to the story. To demonstrate the functionality of FlexRAM, this gallium liquid metal gallium RAM they created, the Tsinghua University in Beijing team encoded a string of letters and numbers onto an array of 8 FlexRAM storage units through a software and hardware setup. And this array is equivalent to 1 byte of data information. Time out for a second, folks. A byte will represent a number or a letter. You have bits that make up a byte, and a byte is a coded representation for a letter or a number. So the digital signal from the computer was converted into an analog one using pulse width modulation to precisely control the oxidation and reduction of the liquid metal. And a quick side note, what is pulse width modulation? Again, for me, I stop in these articles and I say, I've got to learn and I've got to share. So pulse width modulation is a method of controlling the average power or amplitude delivered by an electrical signal. So that's what that's all about.
So those who clearly remember their high school, engineering classes, the little wave, either really tight together or really long wave amplitude. Yeah.
There you go. There it is. Exactly. Good. And the gallium-based liquid metal droplets are encased in EcoFlex, a stretchable biopolymer. The researchers used a 3D printer to create EcoFlex molds and injected the gallium-based liquid metal droplets and a solution of polyvinyl acetate hydrogel separately into the cavities in the mold. This process increases the device's resistance ratio and prevents solution leakage. That paragraph was extraordinarily geeky, but I do like the fact that they brought in 3D printing into this process. Now, here's some qualifiers. Time to get real. The current prototype is a volatile memory, which of course that's okay, but has shown the ability to retain data for up to 12 hours, even when the power is switched off. This feature, combined with its stable performance for more than 3,500 cycles of operation, suggests that FlexRAM could be developed into different forms of memory. And the liquid metal RAM also demonstrated impressive stability, even under extreme deformations, such as 100% stretching, 180 degrees bending, 360 degrees twisting. Wow. This resistance hints at exciting possibilities for the use in the future for soft, intelligent robots, brain-machine interface systems, could be medical, right? And wearable implantable electronics. But Ben, I want to stress, as we do very often with some of these stories, we are talking about very, very early results of very early research. Remember, they were only able at this stage to represent a single byte, a single letter or number. Right. We're not talking about the spectacular amount like my computer has, 32 gigs of RAM. We're not talking about anything remotely close, but it is the beginning of a journey that might lead to something spectacularly revolutionary, and that's why I wanted to share this story.
The proof of concept is yes, a very important first step to this. And yeah, I like, being able to store that one letter and, being able to twist it, malform it or whatever, and it kind of, keeps doing what it does. It's important. And it's also important, like you said, for those robots where, if you want them super bendable, stretchable, durable, whatever, and the more components you can get that aren't, super rigid. So, you still have your mother, or, some form of motherboard with your processor, but hey, at least your RAM will never lose data. Stuff like that is very important. So
interesting.
First proof of concept, and hopefully not the last, because if it works with this, hey, maybe it'll work one day with a processor, not just the RAM, but with the processor as well. Who knows?
Yeah. And you know what, Ben? Another thing we do every Friday is give you stuff, sometimes it's weirdo stuff, out there stuff you're not going to hear on your nightly news, on your major networks. It's understandable. They've got other things they have to deal with, but that's what we do. We bring you insights on some strange and interesting and out there trend and early research stuff.
Yeah, Ralph has never really come on the show and been like, "Hey Ben, here's the latest sales figures from Instacart." The stuff that does get covered kind of seems a little superfluous for the everyday listener. But this stuff is at least fun. I will say.
Yes, it is.
So with that being said, story number 2, and this has to do with semiconductors, and I think we're all very used to when we see like chips and stuff, and just that green color, that just kind of represents a circuit board, and like we all kind of associate that's what a computer chip looks like. And I guess scientists are even starting to get to the fundamental building blocks of what computers are made out of, and that's always good research, good advancements. So story number 2 really strikes at the heart of this with turning, Ralph, I'll go ahead and let you say it for story number 2.
Yeah, this is real interesting. And there's a lot of qualifiers to this story. I'll explain. This comes from interestingengineering.com, a great website. Headline: Scientists turn glass into a transparent semiconductor using a laser. And so that's very, very interesting. Right away, if you think semiconductor, most of us understandably think about, the brain chips in our computer or that sort of. No, we're talking about a different kind of usage for semiconductors, and we'll get into that here with this story. But again, it's interesting that they're using glass, which is fun. And there's some qualifiers too on what kind of glass they're doing and how they're doing it, and the equipment used and so forth. But I'm jumping ahead of myself. So in the show notes, you'll see a photo, and we're showing it on, for those of you who are looking at our YouTube presentation, you can see a person holding this little green circuit board-like thing. But in the middle there is the clear glass they're talking about that's performing the semiconductor function. Okay, so here we go. A team of scientists from the Swiss Federal Institute of Technology, Lausanne, which is in Switzerland, and Tokyo Institute of Technology discovered that they could turn ordinary glass. I'm going to stop. You're going to find out it's really not ordinary glass, but that's okay. We'll get into that. So they've discovered they could turn ordinary glass into a light-powered semiconductor using a femtosecond laser. That's FEMTO second laser, a significant breakthrough in material science. The research, published in Physical Review Applied, has opened up new possibilities for various applications, such as smart windows and sensors. So we're not talking about something that's going to be in your computer. It's going to be maybe something a part of your future windows or other kinds of sensors that are exposed to light. Okay?
And here I was thinking you just take your empty beer bottle and set it on your femto laser that you have at home, and you turn it into a computer, I guess, right?
Yeah, that's
I guess not.
Not quite, but it's still darned interesting. Okay. So side note, here's where I, had to insert myself because I needed the education. What the heck is a femtosecond laser? I'd never heard of this. A femtosecond laser is one that emits optical pulses with a duration of a femtosecond. Okay, what's a femtosecond? A femtosecond is ultra short. Get ready, being 1/4 of a second?
Mm-hmm.
How do you physically pull this off? I don't understand it. And note, a quadrillion is equal to 1,000 trillions or 1,000,000 billions. I always feel like Austin Powers, billions.
To put it into terms I think everyone would understand very easily, that's about what is that? That's about 333 apples in terms of valuation. So yeah, that's about right.
Yeah. but a quadrillionth of a second. How can you possibly have bursts? I don't.
Yes,
I don't understand it.
Humans don't do large numbers very well, but safe to say that is right. Not usually a measurement of time that we really associate. So it's very short.
So again, you have glass and you have this laser, and this is how they're making this semiconductor using glass. But now let's talk about the glass. The scientists were interested in the behavior of atoms in tellurite glass, which contains tellurium, I hope I'm saying that right, when exposed to ultra-fast pulses of high-energy laser light, the femto laser. They were surprised to discover that the laser created tiny crystals of tellurium and tellurium oxide, both semiconducting materials, inside the glass, precisely where the light hit. This finding implies that the glass could generate electricity when exposed to daylight. Okay, that's interesting. I do want to do a little kind of fact check or reality check, if you want to say. At the beginning of the articles, we said the headline infers, or the opening words infer, that what we're talking about is glass, just common glass, and this laser equals a semiconductor. Well, it turns out, I did a little extra research, that tellurite glass is not really common. It's glass not commonly encountered, one reference said, but it has unique properties that make it valuable in specific technological contexts. So, Ben, to your point about a beer bottle or your pickle jar we're not talking about that silica-based glass. We're talking about something called tellurite glass, which is not that common. So it's a little qualifier here, and we're going to find out about these femto lasers in a moment too. But what is tellurium? I can't say it. Right.
Tellurite, yeah. Tellurium.
Yeah, go ahead, Ben.
Yeah, no. And by the way, I just went to go Google it, and of course, the first thing that popped up in the Google search was the tellurite. So I know that our audience is not nerdy at all. It is not the race from Star Trek that are warp-capable pig-leg humans. No, this is tellurium, or however you say that, Ralph. I'm having trouble too.
Maybe. Yeah, I'll try. Let's try tellurium. That's
tellurium. There you go. Okay, but yeah, not the same.
If you're listening to us, it's tellurium. Okay, and it's a very brittle, non-malleable, silver white metalloid. And a side note: what is tellurite glass? Distinct from silica-based glass, which is what we would think in our beer bottle and our pickle jar and so on, is a fascinating material with unique properties. It contains the element tellurium, which is positioned 2 elements down and 2 elements over from silicon on the periodic table. I even put a periodic table with arrows showing you where that is to geek out on that for a second. So back to the story here. The team was thrilled with this discovery and saw the potential for creating durable patterns on the glass surface that could produce electricity when illuminated, when exposed to light. This is a significant breakthrough because the technique does not require any additional materials. And all that is needed is the tellurite glass and a femtosecond laser to create an active photoconductive material. Time out for a second here, folks. We've already explained that tellurite glass is not your typical normal glass. That's one factor in reality. The second factor is these good old femtosecond lasers. Well, can I go to Radio Shack? Oh, they don't have Radio Shack anymore, do they? Can I go to Target and get one? No. These guys, these femtosecond lasers cost on average between $400,000 to $500,000. So maybe in a mass production factory situation, you could get the cost of production down to make this feasible and so forth. I'm not saying that's not possible, but I do want to put some reality checks. Not a common form of glass, and very expensive machine needed to make this effect happen.
Right.
Yeah, pretty interesting.
I just went online and tried to Google, buy femtosecond laser, and looks like they're mainly used for like medical equipment and stuff like that. I guess there's different use cases for them. So
that's right.
It's very cool that they use a glass already found with the technology already, mass produced. Like, it's not that you can't get them; they're just prohibitively expensive. And they turn it into something completely new, and that is cool.
Yeah. And that is very cool. And it's, again, a great example of how science and researchers and people go, well, there's this glass that has this kind of properties, and that's kind of interesting. Oh, and a femto, what if we? And I never can understand how they put these things together. And again, sometimes, not to beat this to death, but sometimes I wonder if AI isn't playing a role behind the scenes, saying they put in the qualifiers of what they're looking for, and the AI goes out there and says, how about telluride glass and a femto laser? Who knows, right? But anyway, to wrap things up here, the Swiss Federal Institute of Technology, Lausanne in Switzerland, team used telluride glass provided by their collaborators at Tokyo Institute of Technology and applied their expertise in femtosecond laser technology to modify the glass and study the effect of the lasers we've been outlining previously here. And they discovered that by drawing a simple line pattern on the surface of the telluride glass disc, 1 centimeter in diameter, that's pretty small, they could create a device that could generate a current when exposed to UV light and the visible spectrum, which could last for months without degradation. So again, folks, early research, is it coming to market next week? No. This could be maybe a decade away or so. Who knows, right? But a very, very interesting thing.
Right.
The potential of this. Yeah, go ahead, Ben.
Ever it comes to market. But, as we say on the show, it's like it's just a building block. It's another piece of information that they can pull from maybe in the future. But still very, very cool. And I teased this way at the beginning, but we're going to go ahead and jump right into story number 3 because I'm excited. It's such a simple idea. And I think in practice, deep mining is, hopefully it's not the most green thing that you can do on Earth. It's really just kind of ripping up a part of the Earth, and we said, the stuff down there is really important. We kind of need it, and we're just going to completely eviscerate the landscape. Not ideal, but Ralph, this is like a good second life for something that after a mine is no longer relevant. It's a good second life and making the best out of something that, unfortunately had to happen. And again, the simplicity of it and just everything about this, I like a lot. So story number 3, let's talk about turning mines into giant batteries.
Yes. And there's a lot of qualifiers here about what we mean by battery. Don't think about your usual battery that you put into your little toys or whatever. That's not the kind of battery. And it's fascinating for that reason. We're going to be talking about something called gravity batteries. So the headline here is Europe's deepest mine to become a giant gravity battery. Well, that headline, how could I resist? And this comes from a news outlet called The Independent, which was posted via MSN. And really fun. Also, I have another link in the show notes to Euronews that covered this story as well. And in the show notes, and what you're seeing if you're watching our video, you can see a picture of the abandoned mine in Finland. And then there's a graph that shows you the idea or the prototype idea for this gravity battery they want to do. So if you're listening to us on a podcast, come out to computeramerica.com, get the show notes, come down and take a look at this material. It's very interesting. So here we go. An abandoned mine, so this is a decommissioned mine in Finland, is set to be transformed into a giant battery, and I qualify battery, we'll get into that, to store renewable energy during periods of excess production of say, wind energy and so forth. The Pi Hasalmi, and believe me, I hope I'm saying that right. It's a very complex Finnish word here. The Pi Hasalmi mine, roughly 450 kilometers north of Helsinki, is Europe's deepest zinc and copper mine and holds the potential to store up to 2 megawatts of energy within its 1,400 meter deep shafts. That's 4,600 feet deep. Wow. Okay. The gravity battery system has been developed by Scottish firm Gravitricity. Clever, kind of the fusion of the words gravity and electricity, right? Gravitricity, which plans to use the Finnish mine as a full-scale prototype to demonstrate the technology. Well, here we go. I went time out. They're assuming I know what a gravity battery is. I don't. So I went out and did some extra homework here on this. So first, what is a gravity battery? battery. All right. A gravity battery is a type of electricity storage device that stores gravitational energy, the energy stored in an object resulting from a change in the height due to gravity, also called potential energy. And you might be going, huh? Bear with us. A gravity battery works by using excess energy, usually from sustainable sources, maybe a wind farm, to raise a mass, in specific a weight, to generate gravitational potential energy, which is then lowered to convert potential energy into electricity through an electric generator. And again, you might still be going, what? Bear with us. One form of gravity battery is one that lowers a mass, such as a block of concrete, to generate electricity. The most common gravity battery is used in pumped storage hydroelectricity, where water is pumped to a higher elevation to store energy and released through water turbines to generate electricity. And I even have a tutorial video on the whole idea of gravity batteries. Now, in that little bit we just talked about, that involved water. We're talking about a weight in the shaft of this incredibly deep mine. All right. So back to our prototype in Finland that this company, Graviticity, wants to do. When there is excess power from wind turbines on a windy day, for example, weights inside this super deep mine shaft, 4,600 feet deep, weights would be wrenched up at the Pyhäsalmi mine's 530 meter auxiliary shaft, using the incoming electricity to generate the wind Using the incoming electricity generated by wind turbines, that energy will be used to raise a huge weight up the shaft. Okay? So it's not a battery like you think of a battery. It's holding potential energy. So instead of that excess energy from the wind farm just going away, not being used, or trying to find some kind of very complex and expensive storage system, how about use that energy to lift a huge weight in this gigantic shaft? And then what?
Yeah, right? I think as like you said, we're used to batteries in our in our everyday objects, and we think, oh, chemical battery, lithium ion battery is the best solution, but. You already got the 5,000 foot, vertical shaft.
Yes.
Why not use that? And that part is really cool.
That's right. So you take the excess energy from, say, a wind farm, and instead of trying to put it into some kind of chemical or other kinds of battery, like we think of batteries, like a Tesla battery in your garage to hold the excess energy from your solar panels, fine, whatever. Not that. Instead of that, use that energy to raise this weight. And then what? Well, later, to generate energy, these weights can be released. This turns the winches into generators. The things that raise the weight now become generators, creating either a short burst of energy or a slower trickle, depending on what's needed. So the humans in control of this thing can say, we need a big burst right away, or we just need a nice steady little, so they can gradually release, and that's generating energy. So that's what they mean by a battery. You have to stretch your mind about what is a battery. And this is a physical kind of battery, not a chemical battery like you were just mentioning before.
And it's very ingenious that you can either do it, there's variable speeds where, you do it very slowly. So this, imagine a, multi-ton chunk of concrete being lowered inches at a time, and it will give you, a bit of electricity. Or imagine it going, feet per second, and it generating a ton of electricity as it goes down. So.
Yeah, it's as straightforward and completely simplistic in many respects as, say, hydroelectricity. Damming up the water and just passing that water through a concentrated channel, turning turbines, and away you go, right? This is kind of mentally in the same category. It's very simple, which I love. So scientists from the International Institute for Applied Systems Analysis found that the world's abandoned mine shafts, so think about the whole world, there's a lot of abandoned mines. Well, if you took all of them and did this with all of them, you could store up to 70 terawatt hours of power, roughly the equivalent of global daily electricity consumption. Global daily, the entire world's daily consumption. If we had all the mines converted to this, they're saying they could store up to 70 terawatts of hours of power, which equals one full day of electricity use around the world, the entire planet. Wow.
And I'm sure that a lot of people know this, but like energy generation is, we've got that pretty good. We know how to do that fairly well.
Yeah.
It's getting electricity to you right when you need it. And that's the part that it's like, if everyone takes their electric cars and puts them on the grid, we can use that as a battery. If we use, I know that Tesla and like other companies have come up with giant chemical batteries that will store energy. Ralph, dealing with those fluctuations in gravity, I read the word gravity. Dealing with those fluctuations in electricity and energy storage is actually like the biggest issue with our energy grid and energy security. So, if you're able to capture and store 100% of your energy generation and still have it on hand, that's going to make everything more efficient. That's going to make everything greener. Like even the dirty kind of electricity, it's still going to make that even cleaner because, hey, you get 100% use out of the electricity.
Yeah, it's a very good point. And again, it's another example of how we've said this so many times before, Ben. There's no one solution, but this is a part of, think of a wheel with spokes. This gravity battery concept is one contributing factor.
So, and I guess the other part they like is that, the places in the world that we have dug mines for the precious resources are, sometimes the countries are not the most technologically advanced. And I like the part that they said that, just by virtue of being a mine, they already have the relevant equipment. They already have the winches, they already have the mine shaft. Generally, they can probably be adapted to the system fairly easily.
A good point.
So, hey, in countries that might not have the infrastructure for these, big systems, maybe this is a good solution for, helping their grid.
Absolutely. And in fact, this is perfect for the conclusion comment in the article. It says the International Institute of Applied Systems Analysis analysts also noted that mines already have the basic infrastructure for doing this while also being connected to the power grid. And they said this significantly reduces the cost and facilities for implementation of underground gravity energy storage plants. So right on target with what you were just saying. So the beauty part of this is the simplicity, the fact that a lot of the constituent components you need to pull this off may already be in the mine itself, and these mines are already plugged into the grid. So the energy they can generate can be fed into the grid. There's no major giant investment needed in many respects. So that's one of the things that I think is so great about this story.
Or really, in other words, like the investment was already made, which was to get the mine there and to mine, kind of mine out. This is like a secondary thing that you can also do this after you're done mining. You can do this as well. And, just going to the website, which, we've been showing on the video portion there, they say that, fast response time, like if you need electricity generation by the second, this thing goes from 0 to full power in less than a second, which just means, the block gets lowered faster, like instantly, and you are able to generate. So, there's so much to like about this story, and Ralph, I like that they tied it into renewable energy because, that's been a concern. It's like, well, it's really sunny right now, but we need the energy at night when it's not so sunny. How do you do that? And something like this works very well. So
I knew you'd love it. It's just so darn clever.
I liked it a lot. Clever is the perfect word. So there you go. Story number 3, like it a lot. Story number 4, and we mentioned, could they have used AI? Well, story number 4 kind of takes that away because they did use AI, and this could have good implications for a lot of people out there because hey, we're going to talk about cancer, and the first rule of cancer, early detection. Kind of important. So story number 4.
You bet. And again, folks, if you're new to our segment, what often we do, pretty much always do, the last story is something from medical technology, which is near and dear to my heart. And the headline here, I think, was really cool. A new artificial intelligence-based risk prediction system could help catch deadly pancreatic cancer cases earlier. So the idea of we can catch this earlier. And this comes from a really great outlet called technologyreview.com. Great story here. So first little setup. Pancreatic cancer is difficult to detect. The pancreas itself is hidden by other organs in the abdomen, making it tough to spot tumors during tests. Patients also rarely experience symptoms in the early stages. Ooh, that's a double whammy, meaning that the majority of cases are diagnosed at an advanced stage once it's already spread to other parts of the body. And this makes it so much harder to cure. So that's the setup. That's the problem that our medical profession faces in dealing with this pancreatic cancer stuff. And as a result, it's essential to try to catch pancreatic cancer at the earliest stage possible. All right, enter a team trying to figure out how can we do this? How can we do early detection? So a team of researchers from MIT's Computer Science and Artificial Intelligence Laboratory worked with a fellow named Lemur Applebaum, a staff scientist in the Department of Radiation Oncology at the Beth Israel Deaconess Medical Center in Boston. So that's the team, MIT and this Lemur Applebaum. So they worked together to develop an AI system that predicts a patient's likelihood of developing pancreatic ductal adenocarcinoma. I'm just going to say pancreatic
adenocarcinoma.
Cancer. Thank you. Which, of course, has the acronym PDAC.
Mm-hmm.
And which is, by the way, the most common form of pancreatic cancer. All right. And again, going forward, so I don't trip all over myself, I'm just going to say pancreatic cancer. Mm-hmm. Okay. The system they created outperformed current diagnostic standards and could someday be used in a clinical setting to identify patients who could benefit from early screening or testing, helping catch the disease earlier and save lives. And this research, by the way, was published just in December, a month or so ago, in the journal eBiomedicine. And I have a link in the show notes for that if you want to geek out on that. Now, the researchers' goal was to create a model capable of predicting a patient's risk of being diagnosed with pancreatic cancer within the next 6 to 18 months, making early stage detection and cure more likely. And to develop it, they examined existing electronic health records. The resulting system, known as PRISM, which I'm sure is an acronym, and I should have found out what that acronym is for. But anyway, known as PRISM, consists of 2 AI models. The first uses artificial neural networks to spot patterns in the data, which includes patients' age, medical history, and lab results. Then it calculates a risk score for an individual patient. The second AI model was fed the same data to generate a score, but used a simpler algorithm. So there's so much more. If you read the paper, you get into much more detail. So we're kind of glossing over here. Now, this part's really interesting. You'll love this. The researchers fed the 2 AI-based models, anonymous data from 6 million electronic health records, 6 million, 35,387 of which were pancreatic cancer cases from 55 healthcare organizations in the United States. Talk about a sweeping, embracing amount of data they went through.
Yeah. So this is the part that that AI in the past, Ralph, has really gotten in trouble for, is that, well, HIPAA kind of exists, which is you're not allowed to, healthcare organizations aren't allowed to share, sell, or do anything with your medical data, because it's your data. But then, Ralph, you get cases like these where, and we already had one of these for glaucoma. We've had these for other types of cancer, heart disease. Like, we've been making AI models of this. And, Ralph, some of them have come, kind of face to face with lawsuits because they're like, did you get written consent for these 6 million electronic health records that you used? And probably not, as you would have guessed. But at the same time, like, they try their best. Is it really anonymous? How much did they really anonymize it? And at the same time, it is going to help. This is going to save people's lives. But HIPAA, and that's just one of the cases where I want to point out to everyone that these cases aren't always clear cut, and legislation always lacks behind, or I should say, lags behind, new technology.
Yeah.
And
Yeah.
this is good. This is going to help people, but the laws on the books say this is illegal, even though it's so cool and so helpful. So that's it.
Yeah. No, it's an excellent point. You would have to think they went to extraordinary efforts to make it anonymous as much as possible. So hopefully that's the case. But you raise a good point. And again, it's a terrible dilemma. The benefit versus the privacy issue. It's a balancing act. You're really right on target with that. And that's something I hadn't thought about when reading this story. I was mainly just so obsessed with the enormous amount of data these people pulled together to make this analysis.
It's for a good cause. And I'm sure that, of those 6 million people, and especially those who suffer from pancreatic cancer, would say, this is great research. Go ahead, use my data. It's just getting that permission. That's the hard part. So, yeah.
Exactly. Yeah. So back into the story here, the team used the models, the 2 AI models we outlined here, to evaluate patients' pancreatic cancer risk every 90 days until there was no more sufficient data or the patient was diagnosed with pancreatic cancer. They followed up on all enrolled patients from 6 months after their first risk evaluation until 18 months after their last risk evaluation to see if they were diagnosed with pancreatic cancer in that time period. Among people who developed pancreatic cancer, the neural network identified 35% of them as high risk 6 to 18 months before their diagnosis, which the authors of this study say is a significant improvement over current screening systems. So a couple of comments from me. Again, early research. Are we saying this is 100% successful? No, they identified 35%. But the researchers said, with all of that in mind, this is still a significant improvement over current screening systems, which inevitably detect something when it's kind of sort of too late. So promising, but it's a beginning step, a trend to watch. So
if somehow we could get people to, everyday people, like, if we could get people to identify you ever seen the captchas, Ralph, where it's like select all the squares with a bicycle in it or something like that?
Yes.
If we could do those with captchas and be like, select all the squares with the pancreatic cancer in this image.
Yes.
We could train it a lot faster, but it's still a very difficult thing, even for a trained physician to do. And this is essentially another tool for those physicians to use.
That's right.
And it's very, very good. And trust me, Ralph, starts with starts here, and they're doing it with pretty much every disease that you can kind of hopefully see coming earlier and earlier. And there'll be a time where, they're going to know, hopefully, 6 months, 18 months, 2 years before things really get, bad, that they can start treating you. And obviously early detection is, key for surviving these things. So it's this research in AI in general is going to help so many cases. So looking forward to that. And again, hey, really fits with the idea of hopeful, which is what Ralph always strives to do. And I think he hit the nail on the head. So for those out there who are following along in the show notes, that's story number 4, and we only cover 4 here on the show. But if you want more, well, Ralph has you covered because he has 3 additional stories. And Ralph, what are honorable mentions?
Yeah, real quick, we'll just give you the headlines and the source, and you can get into the show notes, come out to computeramerica.com, get the links, dive in as you want to. Headline, first one story from The Cool Down, which is an interesting outlet. Scientists develop game-changing glass brick that could revolutionize construction, the highest insulating performance. So that's a fun thing.
I got to show that one to my mom. I went through a big renovation a couple of years ago, and Ralph, I don't know if it's the time period. I don't know what it is. Yeah. She is in love with glass blocks. I hate them to the ends of the earth. I think they're so tacky, and she's like, I need to put glass blocks in every bathroom. I'm like, why? They're awful. They're awful. But hey, maybe if they were high insulating, then maybe I'd like them more.
Yeah. So that's a fun story if you're interested in the building construction area. And then the next story, headline here, is a tech review. Flexible solar panel is thin, light, and tough and is easy to mount. This comes from the Tribune News Service via MSN posting. And the image in the show notes shows you just how flexible and thin this solar panel is. That's kind of fun. Another advancement in that whole field. And then the next story here is engineers fashion strands of conductive fiber that can be woven into clothes. We've talked about this kind of technology, Ben, many, many times before. The whole idea of trying to create smart clothing or clothing that can create energy as you're walking around and exposed to light and so on. That story comes from techexplorer.com. And that's an interesting one too as well. So those are some additional homework assignments for everybody.
For your enjoyment, of course. And Ralph, I want to thank you so much for bringing us these stories. They were great as always. And this week was really, really fun as well. So with that being said, everyone, if you want to hear more of this, well, Ralph Vaughn joins us every single Friday. And of course, you can go to our site and find his past shows as well. It's full of more stuff like this. And we have all the shows going back for a couple of, years at this point. So, Ralph, I want to thank you so much for joining us and bringing us these stories. Everyone out there, thank you for tuning in, and we appreciate that. We'll catch you here next time, everyone. See you on the next show. I hope you have a great weekend. Do something fun. And everyone, thank you so much. Have a good one. Bye-bye.